Hello, Jameson. We're with Mr. P again.
Hello, Jameson.
This is the second time I'm doing this, so it's mighty embarrassing for me. So here we have the graph. It's terribly drawn. So A is asking us to determine the horizontal and vertical intercept and describe what the point of interception represents. So the point of interception is where it intercepts on the y or x axis. So first we're going to start with the x axis. And here I already have the bracket set out because I already did this and failed. So the x axis, you always start with x, which is 5. Oh my god. Focusing the camera is going to be a pain. And since it's just 0, it's 0. That makes no sense. I put it in the wrong spot. That's supposed to be right there. Anyways, now we're going to move on to the vertical interception. So that was the horizontal intercept. So now we're going to go up here to the vertical intercept, which is, so we always start with the x-axis, which is 0. And then we go to the y, which is 60. That's terribly drawn. And what does it represent? How much gas you started with and the distance you traveled. Because here you have fuel left in the tank and distance hundreds of kilometers. B, okay. B, determine the rate of change. What does it represent? So the rate of change would be, it's always rise over run. So we have rise over run, which equals like the slope or the rate of change. This is very tedious. Anyways, so the rise we're going to start with is technically actually going down. So it's going to be negative 60. So we go here. Oh, what's it asking me? Determine the rate of change. Okay, yeah. So negative 60 over 5, which is the run. So that's our rate of change, negative 60 over 5, which can be simplified to negative 12 over 5. Right? He says, no? Why not?
I'm not going to tell you.
No? Why isn't it negative 12 over 5? Please.
I don't want to tell you the answer.
Please tell me.
No.
Please tell me.
What'd you do, Kim?
It's not a block.
Huh?
What's 60 divided by 5?
12.
What's 12 divided by 5?
I don't know. Oh, I can't do that, can I? Well, when do I simplify it, Mr. P?
You did simplify, but you don't leave the 5 there.
Why?
Because it's wrong.
Oh, I see my mistake. Good thing Mr. Patrick's here. It's actually negative 12 over 1.
Yeah.
The 1, there we go. Okay. So this is an educational video.
Yeah, you're learning.
This is an excellent example of how we can make mistakes, but sometimes we can rectify those mistakes. So thank you for Mr. Patrick. And Mr. Patrick can now explain, what does it represent?
I'm not telling you.
You're not telling me. Okay, that's very helpful. So it represents, shoot. It represents how much fuel you have after a certain number of kilometers. No.
That's not your change. What's changing?
What's changing? The changing is the... Oh, the fuel is changing.
Mm-hmm. And what's making it change?
The distance.
So what's your rate of change?
That's the worst way to explain it.
What's changing and what's making it change?
That's the independent.
Oh, it's
Yeah.
negative amount of liters over... What?
What's changing and what's making it change?
So the fuel in the tank is changing and the distance is changing it. So however kilometers you travel.
Cam, if I trade my car for a big truck,
Yes.
what's going to get worse about my vehicle?
It's going to get worn out.
No.
Less fuel in the tank.
Faster.
Faster?
Yes.
Okay,
So if I put $100 in my car and drive to show, or I put $100 in a 3/4 ton truck, what's going to be worse?
I feel like you're making this more complicated than it needs to be.
No.
No? Okay. I'm going to move on until I come back to that because clearly I
Okay.
should have prepared more. Determine the independent variable. So the independent is always the x-axis. So it's the distance in this instance. So distance Yeah, Mr. P's giving me the nod. Distance. And the independent is always the y-axis, which is fuel left in the tank. Fuel in tank. Okay. D. Determine the domain. Oh, that was D. Okay, E. How much fuel is left in the tank after traveling 200 kilometers? So we go over here. So this is this is in hundreds of kilometers. So this would be 200, 100, 200. So here, now we just go up and over, and that would be roughly like what? So that's. I should have figured this out before I started the video. I just want to get this done. I'm gonna remake another one when I get home and actually have to turn in this review book. So that's roughly. What's half of 12? 6. So that's 18. So that's like what? 20? 22, would you say?
21.
21?
That'd be 22. You're right.
22? I'm correct. So it's coming up from him. If I'm being misled, it's on him, it's not on me.
But that depends how well your graph is drawn.
Well, it is very poorly drawn. Okay, so that was E. Oh yeah, okay, so about 21 liters left in tank. Or wasn't the consensus that it was 22? 22.
Yeah, I think it's
22. Okay, yeah. And F. And this will be the synopsis of this awful video. What distance has been traveled if you have 30 liters left in the tank? So it's the same idea here. We're gonna try and find 30. So this is going up by 6, so that's 30 right there. And so we just go over, boom, and then down. And that's like, okay, so that would be 1.5. It's like 1.4, 1.3, do you think? Or which would be 130, 140 kilometers?
Damn, your graph's not this skill at all.
Oh, whatever. 140, 130, what are we estimating?
It looks like 140, yeah.
140 kilometers. Okay, I just need the video. I can make a better video later. I just need a video. Okay, now, Mr. P, do you want to answer this now? What does it represent?
What does it represent, Cam? What is changing and what's making it change?
The fuel is changing and the distance is making it change because this is the dependent and this is the independent. This depends on that.
Okay, so what rate of change exists involving rate of fuel in the tank leaving by distance?
The amount of fuel you're losing per kilometer?
Yes, or fuel efficiency.
Okay, so the amount of liters you're losing based off of the number of hundreds of kilometers. So every 100 kilometers, you lose 12 liters. Mm-hmm. I'm not going to write that because I'm tired of writing. That's Jameson. Oh, wow.
You also didn't answer D.
D? Determine the rate of change. And oh, yeah, okay. Graph and set notation. Oh, my gosh. Okay. So, determine the domain and range. So here we're going to go D, which is domain, and squiggly line. X is, what is this? What does that straight line mean again?
Is an element of?
No. Element of is, I'm correcting Mr. P here. X is element of the reals. That's what that is. Mm-hmm. So what's that straight line?
I don't remember.
He doesn't remember. This is not on me. So anyways, so it goes over, the farthest left X goes is 0. So it would be 0, and then X is greater than or equal to 0, and then something else, 5, because that's the farthest right it goes is 5. So 5, and then semicolon, X is the element of the reals, squiggly line. Now, so that is the domain. Now we're going to go to range. Range, boop, boop. That's a terrible line. Boop, boop, boop. Y is like as much as or something like, I don't know, it's something like that. But anyways, the farthest down Y goes is 0. So 0, y is greater than or equal to 0. And the highest up it goes is 60. So it'd be 60 is greater than or equal to y. And then something, whatever that is, y is an element of the reals, close bracket. That's that. Mr. P, any closing statements? Are you going to say that I'm just the greatest math student you ever had?
Greatest math student I ever had.
You
Top
think-
200.
That's
All
amazing.
time.
All time. Perfect. Thank you, Mr. P. Asher, please be quiet.